Hi everyone, welcome to the Virtual SAN webinar. My name is Pooja Virkud and I work in the storage product marketing team at VMware. And today I'm going to be talking about Virtual SAN and specifically around how it can lower the storage costs in your environment. Before we get started, for the folks on the call who are not exactly familiar with all the details of Virtual SAN, I'll just give you a brief and quick introduction. Virtual SAN is VMware's hyper-converged storage solution. It is completely software-defined and built from the ground up for your vSphere virtual machines. It abstracts and aggregates locally attached disks in a vSphere cluster to create a storage solution that can be provisioned and managed basically from your vCenter and your vSphere web client. The key thing about vSAN is that one of the great parts about its architecture is that it uses flash for accelerating storage I/O, which means you can really provide good and high performance for some of the most critical applications in your data center. Now, the other thing about vSAN is that it is what we sometimes call as hypervisor converged. And the reason we call that is because the Virtual SAN software basically runs inside the vSphere kernel. That means that storage and compute for your VMs is delivered from the same x86 platform which is running your hypervisor. And basically you do not need to install another storage appliance or a separate storage VM. Everything comes right inside your hypervisor kernel. This also provides that additional level of integration with the entire VMware stack, including features like vMotion, HA, DRS, etc. And then there are other aspects of vSAN which will go into things like storage provisioning and how it makes your entire storage operational model much simpler. So that's a little bit about vSAN in a nutshell. The question we often get is where do I use it in my data center? I mean, I know it integrates with vSphere and works great in VMware environments. But the key thing to remember here is that you can basically use it anywhere. It's built from the ground up for all your vSphere VMs. There is a significant amount of the simplicity, performance, scalability, cost savings that can be applicable to most of your applications in the data center. So basically, if you are running your workloads on VMware, be it business critical, be it things like virtual desktop, even tier 2, tier 3 or test dev workloads, all of that is very suitable for vSAN. In fact, even for your DR sites or your recovery sites, we have several customers using vSAN out there because of a lot of the cost saving advantages and benefits that we will talk about in the next slide. So again, the key thing is you can use it anywhere in your virtual infrastructure. If your applications are running on VMware inside the VM, you can use vSAN for storage. Now let's see how it simplifies the storage operational model, because this is going to be very key in our discussion about the overall TCO of vSAN. So vSAN is managed through the vSphere web client and the vCenter server, which is basically all the tools that you're already familiar with in your VMware environment. It is enabled at a cluster level, and it can be just simply turned on by clicking a radio button, as you can see. Management is again done through this the same tool set. And not only does this mean that you don't need to learn a new management tool out there, you also don't need to worry about taking a specialized training course or learning something very specific about storage. This whole concept of vSAN management completely integrated with your existing VMware environment makes just the management and provisioning of storage much simpler and much closer to your existing virtualization workflows that you're already familiar with. Second, vSAN provides very key automation capabilities. It uses what we call the storage policy-based management framework, which essentially does what the name suggests. Basically, it manages storage using policies. Specifically, it allows you to define storage requirements on a per VM basis. Thus, you can specify your needs based on the needs of the applications which are running inside those VMs. Just simply define the amount of capacity, performance, and availability for each VM. vSAN will then match those requirements to the underlying storage infrastructure. Unlike where, in a case where in a traditional external storage where provisioning is done at the storage layer, it's a much more, rigid hardware-centric approach. vSAN puts the application in charge by allowing you to provision and control storage in a much more VM and application-centric way. It abstracts that underlying hardware and automates that ongoing management of SLAs which are assigned to the VMs. And the end result is basically you don't have to worry about, configuring LUNs and volumes, then thinking about, how your VMs are getting the SLAs that they need or possibly migrating them and things like that. You just, simplify that whole model by going with the storage policy-based management approach that vSAN provides. Finally, and probably one of the most important aspects of going with a vSAN-like hyper-converged architecture is the elastic scalability, or in other words, the right sizing of your storage to fit your needs. vSAN allows you to either scale up or scale out your cluster. So what do we mean by that? In scale out, you can just add another server to add capacity and performance. Each server contributes hard drives to increase the capacity or a SSD drive to contribute performance. So basically, you've just added another server and you've increased capacity and performance. Or you can scale up. That is, you can add only just the hard drives for increasing capacity, or only the flash drives or SSDs for increasing your performance. So the end result is you are able to elastically and granularly scale your storage system actually in a non-disruptive way. It's very, very effective for sort of building out whatever you need in your data center in a much more modular sort of building block approach. And of course, from a cost perspective, it eliminates the need to make large upfront investments and gives you linear predictability for forecasting purposes. Every single vSAN customer actually that I know of really likes this capability, especially given the trend towards the distributed scale-out applications that we're seeing these days. Virtual SAN also allows the ability to create an all-flash architecture in which SSDs are used for caching as well as data persistence. In this architecture, the flash cache is used completely for write caching. So unlike in the hybrid architecture where you have two tiers, first tier was flash-based, the second tier for data persistence was based on magnetic drives. Here you have both tiers. You still have the caching tier, which is based on flash, but you have the data persistence tier, which uses only SSDs. Now, this two-tier architecture allows tiering of SSDs because a write-intensive, high-endurance SSD can be used in the caching tier for the writes, and read-intensive, cost-effective sort of SSDs can be used for data persistence in the persistence tier. So this allows you to sort of tier the cost of your all-flash architecture. Now, the good part, obviously, with an all-flash sort of approach is that it provides consistent, predictable performance with up to 90,000 IOPS per host and sub-millisecond response times. And this is critical because this sub-millisecond response times make it ideal for applications in sort of tier 1 workloads or any applications that require consistent, predictable performance. Let's look at how a two-tier flash model like vSAN's contributes to cost savings specifically. So in this example, a customer expects that he will need to deploy about 10 terabytes of all-flash storage for supporting certain tier 1 very performance-sensitive applications. Now, on average, these apps are writing about 3 terabytes per day. So in a single tier model, where, there's obviously just a single tier of flash. The writes can therefore randomly hit any SSDs that you have in that tier. So if you use, since you need 10 terabytes, if you use 12 800 gig write-intensive SSDs, you will need to spend about $60,000. The other option you have is to, use cheaper read-intensive SSDs, which can help you lower your cost. But remember that endurance is a key criteria when selecting flash drives. So if you will have to take into account, how long those SSDs can last and at what point will you need to replace them. So since you are using read-intensive SSDs, you will have to replace them, approximately every 2 years or so, and your cost will end up being about $51,000. So it's approximately in the range of that 51 to $60,000, depending upon what type of SSDs you choose. Now that is in a one-tier model, a single-tier model. If you have a two-tier model, like is there in vSAN, what happens is that the use of flash media is optimized. So approximately 10% of SSDs in vSAN is used for the write caching tier, while the rest is used for sort of read purposes. So you can use a combination of just two write-intensive SSDs for a cost of about $10,000. So we are basically using the same SSDs we used in the previous model, but we are using fewer of them, just two of the write-intensive ones, at about $5,000 per SSD. That comes to about $10,000. And then the rest you just use read-intensive SSDs. So use about 10 of those read-intensive SSDs, which will result in a total cost of about $17,000. And so if you combine those two, you still have your 10 terabytes of flash storage, but it is in this tiered fashion, and the overall cost of it is coming to about $27,000. So as you can see, it results in 47% lower cost just using a two-tier model. So these kind of architectural elements and considerations are very important when you look at what really contributes to the overall TCO of your storage solution and specifically your vSAN solution. So let's look at what some virtual SAN customers were actually able to achieve for different metrics. So one of the examples that we have is from Union Hospital, and this is a case study that we'll look into more detail later. But from the different aspects of how they were able to save storage costs when using vSAN, one of the key things that they highlighted was just simply the operational benefits of going with vSAN. So they were actually able to cut down their OPEX cost and overall, management and sort of maintenance cost by using vSAN to about 1/10 of what they were earlier seeing on their SANs that they had for their same applications earlier. So really about 90% savings from an operational perspective for Union Hospital. The other customer that we looked at, talked a lot about some of the performance benefits that they saw, and this is kind of touching upon the architectural discussion that we had earlier about using, flash for both caching and sometimes even for data persistence, just going with an all-flash model. We have various customers who have used, both combinations in their data center, but in general, just the architecture of vSAN and the way it handles storage I/O, most of our customers have seen excellent performance in terms of IOPS. And Peter Kramer is an example where, they specifically commented on really low, sub-millisecond latencies, especially for some of their reporting applications when deployed on vSAN. And then finally, we have another customer who's used vSAN for a virtual desktop environment. Oregon State University, they said they were able to reduce their VDI storage cost by as much as 60% when going with a vSAN-like solution versus a traditional storage array. And this is also another case study that we'll look at a little bit more into detail. But these were just some of the sort of metrics that I wanted to highlight in terms of the discussion we'll have later about, how some of these cost savings came into effect and, the different aspects of both CapEx as well as OpEx savings that customers specifically commented on. So what is really driving the cost of storage? Gartner publishes a report annually. It is called the IT Key Metrics Report. And this shows you how the annual storage costs are actually broken down into its various components. So of course, not surprisingly, hardware is definitely one of the biggest components at 47%. Another key component obviously is about at 13% is software. But from what you see, the rest is all, rest of your annual storage cost, which is as much as 40%, is all just OpEx. So there's labor costs, facilities costs, connectivity, all those different components which all come under the category of OpEx. So imagine if you could just, how much of that cost you could actually reclaim if you could use a storage solution that lowers your OpEx cost as well. So not only would you, save on those additional dollars, but also just result in overall better admin productivity, and all those time and hours can then be deployed to doing just more strategic projects in the organization. And of course, like we see, the CapEx also being a big piece, if there is another way to reclaim some of those hardware costs as well, just using newer architecture, then obviously the solution is something that allows you to lower your overall TCO as well. With Virtual SAN, we see cost savings on both sides, CapEx and OpEx. With the ability to use server-side components, we can significantly lower hardware costs. We'll go into more details about this in the next slide. Scaling is another big factor. Obviously, you're just adding servers or disks, and that is super cheap versus just going out and buying a completely new SAN. We'll see how those scaling costs compare when using the traditional storage array method versus the vSAN method. And then, just simple things like just providing higher resource utilization, just having a more predictable cost curve on an ongoing basis, all these different aspects which contribute a lot to your CapEx calculations. And then, of course, we mustn't forget the OpEx piece, which we just saw that it's a pretty high, significant number in the data center. Higher admin productivity, no need to actually spend hours just going back and forth between teams to just handle storage provisioning. You don't need specialized skill sets because you're automatically using, the same tools and environment that you're already familiar with on a VMware platform basis. So overall, just, a solution which caters to both benefits. And when we actually looked at the numbers, we saw that if you calculate it on both a per IOPS as well as per gigabyte or per desktop basis, the numbers are very low. So we see about 25 cents per IOPS when you from a performance perspective, as well as about 33 cents per gigabyte when you look at factoring in both the CapEx and OpEx from a vSAN point of view. So we'll go into specific aspects of this, but overall we saw about 50% TCO reduction in a vSAN environment, and that's pretty much from our calculations. From the other numbers that you saw from our customers, some of them had even higher, depending upon what they were comparing it to earlier. Now, the first point I want to make is around server-side economics. So we used some of the Gartner competitive profiles databases to pull the numbers on the list prices of the various components we will compare here. What we'll compare is the traditional sort of storage array, going and buying it from your storage vendor versus the server-side storage and how those two, differ. And I'm talking only about the component parts here. Example, just buying a single hard drive from a storage array vendor versus buying a server-side hard drive from your server vendor. So first up, we looked at the hard drive. So the example here is of a 7.2K NLSAS 1 terabyte hard drive. The list price cost about $895 with a storage from a storage array vendor, resulting in about approximately 49 or like 50 cents per gigabyte. Going online and adding the same type of hard drive to a server costs about 80% less. That is, it costs us about $110. That is about 10 cents a gig. So you can see pretty significant savings in just going with a server-side sort of component. Same goes for flash drives. We used a 200 gigabyte SSD flash drive inside the storage array. Looking at the dollars per gigabyte, it came out to about 22.48. And placing the same type and size of SSD in a server will cost you about 92% less at 1.85 per gigabyte. If you look at external SANs today, most storage arrays require fiber channel networking, which with a switch and fiber channel NIC costs around $12.35 for every port. With vSAN, you can take advantage of a 10 gig network and save about 70% in your networking costs per port. So just imagine how all of these different component costs will, add up to a lot of savings on a typical 8 to 10 node cluster. Now, hardware prices are not a constant. They change often, they most likely often go down. Let's see how you can take advantage of a declining cost curve by just taking advantage of how the cost of SSDs and hard drives is quickly declining. When you choose to go with a traditional storage array, you elect to pay upfront, and therefore in most cases you paid a lot more money today for future use of your storage. That is, you overpaid in terms of time. Instead, if you bought only what you need every year, you can take advantage of this declining cost trend. Electing to use technologies like vSAN allows you to enjoy the decline in cost curve by spreading your purchases a little bit more across time. A side effect, obviously, is that you no longer need to think about storage growth needs before you get a requirement for growing compute resources. That is, when new applications need to be deployed and new servers need to be purchased, you just grow your storage at that time. Because in this architecture, both storage and compute can grow simultaneously. You do not need to pre-purchase storage and keep it aside beforehand. The third point is that you can stay on trend with the rapidly changing storage hardware technologies. For instance, PCIe flash cards with growing speeds are becoming more mainstream today. We also have NVMe SSDs and flash on DIMM, which already seems to be the next evolution to a better flash technology. All of these can be implemented quickly and easily on your servers with a hyper-converged software-defined solution like vSAN, which allows you to take advantage of all these new trends as they come to market. How does low upfront investment and granular scaling help you? Let's take a little bit more deep dive into that. The actual dollar savings or granular scaling may not seem obvious initially, but looking at this graph, you can see that besides the total cost savings, just the total amount you spend, comparing a storage array and an equivalent vSAN deployment, you avoid the large upfront cost you have to make at the beginning of year one. So obviously there is no guessing here. If you need 5 terabytes, then all you buy is the 5 terabytes in year one with vSAN. The implication of this, and that's something most storage vendors won't tell you, is that the effective dollars per gigabyte that you are paying, is significantly different, for the two. So if you're paying 100K upfront and using only 5 terabytes out of your 20 that you purchased, the price that you paid in year one is much higher than what a traditional storage array vendor will tell you. So that's why you see the big difference between those two lines on the right side chart for going with a vSAN-like approach versus that hybrid array upfront investment that you have to make. With vSAN, like you see, the effective dollar per gigabyte is much more linear. You will pay almost the same price year after year, since what you're doing is just buying what you need when you need it. So that linear sort of scaling just is something a lot more suitable to most businesses, because they don't need to pre-plan a lot of their investments for a few years in advance like they have to do with a traditional solution. One of the best use cases for vSAN is virtual desktops. Very write-intensive sort of workloads. They require high performance, and of course, most of the times earlier they used to be deployed on traditional storage systems because that's all that was available. And when you needed to scale your desktop environment, it became very costly using a storage array. So on this chart, the line on the top shows the dollars per desktop, that is a storage cost, is usually declining, like you see from the initial purchase, because as you deploy more desktops, the cost keeps going down. However, it hits a certain point where the number of desktops you can deploy gets limited by the IOPS available on the array. Now, this limitation usually doesn't end up being a capacity threshold. It's most likely the performance threshold of those arrays. So, that's why your limitations come up in terms of the amount of IOPS available for your virtual desktops. So after you hit that point, the next desktop that you need to deploy becomes very, very costly, and you end up seeing that sawtooth effect because this next desktop requires new storage that brings the dollars per desktop all the way back to the higher point. On the chart, the bottom two lines are for vSAN, and the top one being for a vSAN with the desktop licensing model that vSAN has, and the bottom one is for vSAN when used with the Horizon suite. In the Horizon environment, using Horizon 6, both advanced and enterprise, you get vSAN included in the Horizon suite. So that's an added advantage, just making the line go even flatter and lower. But essentially, both those lines, follow a similar pattern, and as you can see, they are very linear, very predictable cost curve. All you need with vSAN when you want to grow your VDI environment is just adding another server, or maybe even just adding individual hard drives or SSD drives, and of course the software license. So these are much smaller incremental costs that don't change a lot across your entire VDI environment. And even when you need to expand that deployment, the whole increase is very linear and predictable. With vSAN, you can flexibly configure your nodes. So you can choose whatever hardware you need to match your application requirements. And then we have what are called multiple approaches to deploying vSAN, but one of the key ones is vSAN ready nodes. So these are pre-validated, OEM configurations, sort of jointly validated and certified by VMware and by the server OEM. And these server configurations, include obviously, the storage controller as well as the hard drives, both magnetic drives and SSD drives, which are certified to run vSAN. And we have these available in different profiles. So, depending upon whether you want certain applications in your data center, or maybe you want it separately for a different VDI type of deployment like we talked about, irrespective, you have, different configurations available. So all you have to look at is the Ready Node guide on the VMware.com page. You will see these different profiles listed as, VDI and server, available for high, medium, and low workloads. So depending upon which you choose, you will see that, the memory, the capacity of the hard drives or the SSD drives is automatically scaled to meet the requirements of that high, medium, low profile. So accordingly, you can deploy a workload that either requires a lot of performance, a lot of IOPS, like you see in that high profile that we have on the leftmost. It is very, very IOPS intensive. It can provide up to 40,000 IOPS per host. And you have a lot more higher grade SSDs with greater SSD capacity used out there. You see that that's the kind of workload you might use for a situation where you're trying to optimize on the dollars per IOPS versus sort of, capacity, dollars per gig is not as important for you. So optimizing on dollars per IOPS, it gives to, about 26 cents per IOP. But as you move to the different profiles, let's say for, the one you see on the complete right, the low profile, these are the kind of ready nodes which are tailored towards sort of more capacity intensive workloads. So they obviously have a lot more emphasis on the magnetic disks which are available, and they are trying to de-emphasize the SSDs or just have the bare minimum amount of SSD available for the caching purposes. So what you're trying to optimize for is actually the dollars per gigabytes. And you see how the the dollars per gigabytes or IOPS changes as you move from profile to profile. So you can pick what you need from an application perspective, and you can also see how it works out from a TCO perspective. We have all these tools available on VMware.com. So the whole ReadyNode page is basically the hardware compatibility guide, which you will see online out there. And we also have a TCO and sizing calculator, which will help you size your overall environment and see what fits your needs. So just visit the Virtual SAN page for that, and we have links at the end of this presentation as well. So switching gears now from CapEx to OpEx. So let's take a look a little bit at the higher resource utilization point that we mentioned earlier. So vSAN takes advantage of this unique storage policy management approach that we talked about, so basically VM level policies, and this helps eliminate many operational inefficiencies compared to a traditional storage solution. So according to Gartner research performed over the years, usually we only end up seeing about 61% of usable capacity of a storage array being utilized. And one of the underlying reasons is the over-provisioning of service levels. To illustrate, for example, a requirement for replication of some VMs in your data center. So by default, because the LUN is the construct, you'll have to replicate all the VMs on that LUN, irrespective of whether you really need to replicate all the VMs or not. So this is, like trying to fit a square peg into a round hole. LUNs and VMs don't speak the same language. When you allocate a LUN with a certain set of SLAs, you are forcing all the VMs on that LUN to inherit these SLAs, whether they need it or not. Besides SLAs, LUN is also an inflexible construct that won't allow you to change its SLAs or size if you need to, resulting in a lot of waste. So when running out of allocation on a LUN, you face three unwanted scenarios. Either you use the LUN with a mismatching SLA level for your VM, and that's not really what you want, or you migrate all your VMs to another data store and reconfigure the array, or you just go ahead and buy a new array. So either way, it's kind of three options which really are not something which you want to do at the end of the day. All this means is that you have to forecast how much storage you might need for the next 3 to 5 years. It becomes a grueling exercise, involving many folks across the organization. You'll have app owners, the VI admin, the storage admin, finance department, everybody having to get together and agree on what storage is needed and what can be budgeted for the next 3 to 5 years so that the SAN can be purchased now. With vSAN, this becomes much easier. Because of the high level of flexibility, you are free to change your mind. And vSAN just takes away the pain of that whole process, right? You can change the SLAs non-disruptively to the VMs. You can buy few disks to answer capacity needs that suddenly come up. Or you can even just boost performance of your application by adding flash or an extra host to the cluster. So really it is, very, very much simplified and all optimized towards providing that higher and better resource utilization for your vSphere cluster. Focusing in on the administration overhead, let's see how much you can save on operations. So in order to put some sort of dollar metrics into how much OpEx savings can vSAN actually deliver, the Taneja group performed some independent testing and analysis on vSAN over time. So this white paper is available and published on, again, the vSAN page on VMware.com, so just feel free to take a look at all the details. But on the left, you can see the 5 main impactful areas where Taneja group found the most time savings around sort of operational storage tasks using vSAN. So things like deployment time, service class configuration, changing service levels for applications, or even scaling capacity, right? All of these, they found very significant time savings, say from 60 to 80% pretty much. All of these result in about 20 to 59% dollars per terabyte savings when using vSAN. And this results in about 2/3 of your labor costs being slashed down, And then we also looked at things like power and cooling costs, which result in about 70% savings when compared to the power consumption of a traditional storage array. So overall, about 50% OpEx savings using vSAN. We also collected some evidence from our customers. Here is an example of a large automaker. We asked them, how much time does it take you from the purchase of a storage array to the day you are operational and actually using it? And they told us it took them about 6 months. The same thing with vSAN, including procurement of servers, hard drives, and even deploying it, along with vSphere and the vSAN software, took them about 2 weeks. So really a big difference there in how fast you can really take your applications to market, right, using a better storage system underneath. Now, if you look at it from the perspective of storage provisioning, that is when you assign and allocate storage to a specific virtual machine, what happens? With a SAN, there is a back and forth with the storage admin, and then you have all the operations obviously around the LUN management, the volumes, static pools, and all that work around storage provisioning. It takes about 4 weeks on the customer side, from the day the request for storage goes out till the day it is actually being used. With vSAN, the same storage provisioning operation took less than 8 hours. Now, before I take you through the specific case studies to actually highlight even more of these points, specific to certain customer use cases, let me just walk you through a quick summary of, again, why so many customers have grown to love vSAN and how they're trying to use it, especially in these different environments. So first up is, one of the things they comment on is the simplicity. It's radically simple. Remember, it is embedded in the vSphere kernel. There is no need to install a separate storage appliance or VM. It uses storage policies to manage the whole provisioning. And then key thing is that it provides that automation. It automatically tunes and rebalances storage to ensure that the VM storage SLAs stay compliant with the policies throughout the life cycle of the VM. You don't need to learn new tools, and of course, it is completely integrated with the VMware stack. So if you're using features like vMotion, HA, and different vSphere features, all of those work seamlessly with vSAN, and even same goes for other sort of VMware products which vSAN integrates with completely. The other thing customers talked about obviously was the performance. We went through this when we looked at the flash caching, and especially the all-flash architecture, which uses a more cost-effective two-tier model. You can deploy almost any kind of applications. It's very good for those latency-sensitive sort of workloads. A good point to point out here is that being embedded in the vSphere kernel, vSAN optimizes the I/O path better than other technologies that require a separate storage virtual appliance or VM to be running on top of vSphere, because it just eliminates that additional hop and just provides better performance downright from there. And of course, the elastic scaling benefits that we already talked about earlier. With regards to TCO, we saw that the hardware-independent architecture can utilize the cheaper server-side industry-standard components. We saw how it actually compares to the storage array versus just going ahead with the server-side economics that you get from vSAN. And then, of course, we saw some of the OpEx benefits of having that level of automation and integration with the virtual environment. So let's look at specific customer stories for vSAN, and we'll drill down a little bit more into the cost savings that they saw on their side. Oregon State University used vSAN for their VDI environment. They managed to cut their VDI storage costs to about 1/3. Initially, they started looking for a new solution because their existing SAN was getting overburdened by VDI workloads. Simple things like user login took as much as 20 minutes during peak hours. As with most IT departments, they had limited storage budget and were skeptical of going out and buying a new SAN, especially when they could not exactly predict, how much storage they needed over the next academic year or two. With vSAN deployed on Dell servers, they not only saved on costs, but also saw dramatic improvements in performance. User logins, which initially took about 20 minutes, now only took 1 minute. They could also scale more by supporting about 170 or so additional users on just their existing servers and network without even buying more. And of course, from an operational perspective, they saw that what they could accomplish earlier in about 10 hours now took less than 2 hours. So really very significant savings, not just on the storage CapEx side for VDI, but also on the operational benefits that they saw. And as a result, they're now actually looking at growing their VDI environment more with vSAN. The customer, no wonder, actually goes on to say that just managing and scaling vSAN is actually just a piece of cake for him. Union Hospital is a healthcare provider based in the Midwest. They are running business-critical applications for EMR, clinic reporting, patient management, and other kind of healthcare apps on vSAN. These applications additionally have Oracle and SQL databases running in the back end. All of this is deployed on vSAN, Cisco, UCS, C-Series servers. And Union Hospital found that they could reduce their storage operations time by as much as 90% after using vSAN. Earlier, they had found about 200 millisecond latencies. Now they found less than 1 millisecond latency after just using the vSAN hybrid configuration. And as a result, since they had a lot of this patient reporting applications, all of their reports ran about 6 times faster for the applications that were deployed on vSAN. So really, again, very significant savings for these guys, specifically from an OpEx perspective as well, what they commented on when compared to a traditional SAN. Gradually, they have been moving more and more of their applications off the traditional SAN onto their vSAN environment. In fact, the customer commented that the clinics and hospital admin staff that the IT department was supporting have been so thrilled with the improvements in their applications that they are requesting that all the hospital applications be migrated to vSAN. So they're a really, really big vSAN champion because they have been seeing a lot of these cost and operational savings that we've talked about across their environment. So again, we saw 2 really good use cases, one for VDI and one for sort of business critical applications, where the customers actually gave us direct metrics on the cost savings using a vSAN hyperconverged sort of approach. Here we have some additional resources for vSAN that you can take a look at. I mentioned the vSAN product page earlier. That has a whole lot of guidance on sort of designing and sizing your vSAN environment. We also have links to specific tools that you can use to look at how vSAN would apply in your own environment. Don't forget to engage with the vSAN community, especially if you have specific questions. And then we offer 2 very interesting ways to actually get a sort of hands-on experience on the product. We have a hosted evaluation, which is called the vSAN Hands-On Lab. The link is available on the slide. And then we also have your own evaluation where you can deploy the software in your own environment and try it out for yourself for free. So go ahead and look at that webpage and see and try out Virtual SAN for yourself. This concludes my part of the presentation. Thank you.